System Practice Homework 8.2, Question 2. Find the inverse Laplace transform of the following functions. Last time we talked about the Laplace transform. This is inverse Laplace transform, and to calculate this, we need to know two things. The first one, we will use this Heaviside-Cartwright method to find the root, and the second, we're gonna use this table to find the pair of the Laplace transform and inverse Laplace transform. And let's start with the first equation. This is the Laplace transform. We simplify this form into the multiply form. For the denominator, s plus 2 times s plus 3. And the denominator is 2s plus 5. And then we know we can simplify the s plus 2 k1 plus s plus 3 k2. And first we use the carve-up method to calculate the k1 and the k2, which is k1 equals to 2s plus 5, s plus 2, s plus 3. We carve up this one, s plus 2 corresponding to the plus 2, and when the s equals to minus 2, so we can calculate to get k1 equals to 1, and similarly we get k2 equals to 2s plus 5 and s plus 2, s plus 3. We cover up this s plus 3, 1s equals to s minus 3, and after calculation we can get k2 equals to 1, 2. So fs equals to s 1 over s plus 2 minus plus 1 over s plus 3. And we use this table, which is pair 2, so we can get the inverse Fourier transform, which is ft equals to e2 minus 2t plus e2 minus 3t ut. Okay, and for the question B, there we can directly we can see that we cannot convert the denominator to the simpler form. So we can use this table. We can see that first we can use it's similar to this one and this one, so we can use this pair of the pair 10D. We can use this two pair directly to get the inverse Fourier transform of these equations. If we use pair 10C, we can see a equals to 3, b equals to 5, and a equals to 2, and c equals to 13. And so b equals to and square roots c minus 2 square which means this is 13 minus 4 equals to 3. And the r is equals to the capital A square times c plus capital B square minus 2 capital A capital B smaller a over c minus a square. So after recalculation, we can get it's equals to 3.18, and the angle theta equals to the arctangent a capital A minus B over capital A times under square c under square roots c minus a square. And we can use the calculator to calculate. Eventually the angle is 6.34 degree. And so we can directly get the inverse Fourier transform. The Laplace transform ft is r times e2 minus at cosine bt plus theta ut, and r equals to 3.018. e2 minus small a is 2, so it's small at, and cosine the b is 3t plus theta, which is 6.34 degree, and times ut. So this is the final answer. Or we can use a pair 10D. It's just all ABC is the same. It's just the expression is different. The inverse Laplace transform form is expression is different. Which is e2 minus at times capital A cosine small bt plus capital B minus capital A over B times sine bt and times ut. And so it's just bring all these values, these parameters in this expression, like e2 minus 2t, capital is 3, cosine 3t plus capital B, which is 5 minus capital A is 3, small a 2 is 6 over small b, which is 3, sine 3t ut. This is minus 1 over 3. So both this is answer of these equations. And for the next equations, C, similarly, first, let's get some simplification. First, let's just open the full expression. So it's s squared plus 2s plus 1 over s squared minus s minus 6. Since this is all is s2, so we can just cancel this out. So we can get some derivation on the denominator. So we can transform this like s squared minus s because we try to cancel it with the denominator. So and then we need plus 3s plus 7, and then on the denominator is s squared, still s squared minus s minus 6. So in this way, then we can get cancel the largest the degree. So we can get a simpler expression like 1 minus 3s plus 3s plus 7 over s squared minus s minus 6, and we convert this into the multiply form, so which is s plus 2 times minus s minus 3, and the denominator is 3s plus 7. So we can see this part actually is similar with the question 1. So we do all other time, we just do the same step as the question 1. So we just k1 over s2 plus k2 over s minus 3, and we use cover up method to find the k1 value, which is 3s plus 7 and s plus 2 s minus 3, and since it's k1 corresponding to 2, so just cover this up. 1s equals to minus 2. We can get the k1 is equal to minus 1.2, and the k2 is 3s plus s over s plus 2 s minus 3. And this time, since k2 is corresponding to s minus 3, so we just set 1s equals to 3. After calculation, we can get the k2 is 3.2. Then fs, we can get the equals 1 minus 0.2 over s plus 2 plus 3.2 over s minus 3. And similarly, we use the pair 5, and this time there is 1, so we still can check this table, which means 1 is inverse Laplace transform 1 actually is corresponding to the delta function, delta t. So first, so ft for this part is delta t, and for all this is e2 lambda t, that ut, that's kind of form. So we can simplify. It's eventually we get the 3.2 e2 3t minus 0.2 times e2 minus 2t, and ut. So this is the final answer for this problem. And for the next equation, we still trying to do some derivation and simplification. 5s squared s plus 2. First, let's try we can write this k1 as plus k2 over s squared, and another form is s plus 2, and we can see if we time this together, we can cancel out the squares, so it's only s. So for here we only need k3, because for example, if we times them together, we can get something like if we times them together, we can get k1 s plus k2 s plus 2 and plus k3 s squared. Then we can, because here is k1 squared, so we can actually cancel out this square term. Right, so let's do some derivation here. It's k1 plus k3 squared and plus 2k1 k2s and plus k2 and we to make the left hand side is always equals to right hand side, so we can get k1 plus k3 actually it's have to be to equal 0, and 2k1 plus k2 it needs to be 0 2, and then 2k2 equals to 5. So we use these three equations, we can put this here, we can get k1 equals to minus 1.25, and then we put k1 in here, we can calculate k3 equals to 1.25. And here is k2 just equals to 2.5, right? So now we can eventually get fs equals to s the k1 over s, so 1.25 minus s, and plus k2 2.5 over square s squared, and plus 1.25 over s plus 2. And see for this two part, actually let's just directly check the table. We need this one, right? And we need this one, and we need this one. So for this is just ut, for this is t times ut, and for this is e to lambda t, which is lambda is the root. So eventually we can just get inverse Laplace transform for ft for first one is corresponding to just ut, so 1.25 directly ut. And first the second part is t times ut, right? So it's plus 2.5 t times ut. And first last part is just need a e to lambda t, so which is plus 1.25 times e to minus 2t ut. Okay, so this is, we can get, of course, make it more compact, so it's 1.5 plus 2.5 t and plus 1.25 e to minus 2t times ut. So this is the final answer of this equation. Thank you.